Very warm greetings everyone. Welcome to the special lecture series of Introduction to Environmental Economics. Today we are going to learn in this particular lecture Environmental Goods, Part A. Learning objective of this particular lecture is to review the definitions of environmental goods, to understand notion of willingness to pay, to comprehend the derivation of demand for environmental goods, to comprehend the use and non-use value of environmental goods, and finally to classify various types of environmental goods. There is an absence of market in major factor, which is a major factor that complicates the derivation of demand curve for environmental goods. The absence of market is not only the problem for environmental goods, it is also a problem for the public goods. For example, education. Education is a non-rivalry in consumption, and therefore the schools that are provided publicly forms the major part in this world, and similarly to derive the demand for the school becomes an issue because the markets are not available for the public goods. Finding the demand for public schooling is a difficult task because of the lack of markets. The biggest difference between the environmental good and ordinary public good is the supply side. Ordinary public goods are produced at a cost. The citizens have a reference point for the cost of the supply they take. So they have an idea about the cost of supply of the public good, and they take into account while understanding or identifying the amount of good that they are demanding for a particular price. However, the amount of goods people demand at a particular price should not have any impact on the value of the consumption. People may have experience and they would have lived in different communities, having a different amount of public good, and therefore they have the idea about the supply side of the public good of education. Or they are aware of the cost of supply of the private schools also. In contrast to this, environmental goods, on the other hand, they are often disconnected from the supply side. No matter how worthwhile the protection of wilderness area may be, it is difficult to anchor that value that since the wilderness area is not produced. One can have some kind of a hypothetical analysis to understand what should be the supply cost of wilderness area. Similarly, the air quality is supplied since there is a cost associated with the cleaning the air. So indirectly we are trying to assess the find the magnitude of air quality by finding the cost associated by cleaning the air. This is a much more dispersed cost, which is much different than that what is associated with the public school cost or a park. Therefore, environmental goods, it becomes a difficult job for determining the demand side of the environmental goods and also finding out the price. The conventional demand curve that shows the relationship between the quantity demanded and the price, and it is usually considered quantity demanded as a function of price, but without the market, when there are no prices, it becomes a difficult task. The concept of demand works perfectly well and makes perfect sense without the markets. Similarly, the consumer supply associated with consuming a certain amount of good is defined in terms of the market transaction. So in such a case, what do we do? The key concept corresponding to the price and the surplus is the willingness to pay, and it is analogous to consumer surplus. In markets we talk about consumer surplus and producer surplus. For the demand side we talk about the consumer surplus. In the absence of market, what do we do? So it is the willingness to pay concept that helps in this case. Suppose we need to derive the demand curve for NOx, which is the pollutant in the air quality, and nitrogen dioxide, and NOx, which corresponds to 3 different levels of the household income. For 1 more unit of NOx, consumers are willing to pay a negative amount. They must be compensated to agree to consume more pollution. So basically what it means that if you want to consume 1 additional unit of NOx, consumers must be compensated to agree to consume to that 1 additional unit of NOx or pollution. The demand curve for this particular case is downward sloping, but since NOx is a bad, therefore we have it in the 4th quadrant. The marginal willingness to pay in this case will be negative when NOx is positive. The idea that it is negative basically reflects that it is bad, and one is not willing to pay for that. It is kind of it should be compensated. If the vertical axis were the marginal willingness to pay for the pollution reduction, then the graph would be in the 1st quadrant, though it will slope upwards to the right. So basically we are talking about a mirror image. As you can see in the graph here on the screens, the same graph can be replicated and have a mirror image in the 1st quadrant. Right now we are in the 4th quadrant, where we are reflecting the willingness to pay in a negative manner, and negative quadrant basically implies that the good is bad, and we have 3 different levels of income, 3 different levels of graph for 3 different levels of income. In the graph, the marginal willingness to pay MWTP for nitrogen oxide, which is given in the units for households at 3 different levels. Household belonging to 3 different income categories. Obviously, a household which is a higher income category is willing to pay a higher amount. It represents the strength of preference of the households for different income levels. The graph shows a negative willingness to pay for increase in the pollution or positive willingness to pay for decrease in pollution. So one can always move backward and forward. If you increase the pollution, it will show a negative willingness to pay, while if you reduce pollution, then automatically the willingness to pay will become positive. At a level of 6 pphm, that level of pollution, that is NOx pollution, lower income household have a marginal willingness to pay to reduce pollution to 5 pphm of approximately $1,000. However, higher income families would be willing to pay twice the amount. The consumer is acquiring 1 more unit of good or giving up a unit of good. If the consumer is giving a unit that is possessed with him, for example selling a liter of gas, then the appropriate term is the marginal willingness to accept the compensation. So there is MWTA concept, which is marginal willingness to accept. In the case of pollution, specifically we speak of the damage from the pollution or the benefits of having less pollution. So we can take pollution in 2 ways. Benefit from reducing the pollution, that is considered as benefit, while the damage from the increase in the pollution. Both of them are actually the 2 sides of the same coin. The marginal benefit of 1 less unit of pollution is the same as marginal damage of 1 more unit of pollution. Furthermore, marginal willingness to pay for 1 more unit of pollution is negative, is considered as negative, because a person will basically be at a loss for consuming the pollution, or he needs to be compensated. Instead of giving the amount, one needs the compensation to consume the pollution, and it should be equal to the negative of the marginal benefit of 1 less unit of pollution or negative of marginal damage of one more unit of pollution. So this is one and the same thing. You can look from the angle of marginal benefit of one less unit, consuming less unit of pollution, or it can also be looked up or from the prism of marginal damage. So it is negative of marginal damage of one more additional unit of pollution. So one can look for the benefit side or damage side. In other words, benefits of less pollution are the other side of the same coin as the damage for one more unit of pollution. When expressed in monetary terms, these benefits and damages are simply the willingness to pay, making sure the sign, positive or negative, is correct or not. So, in a hypothetical scenario or a framework, individual demand curve for the two commodities we consider, one is gasoline, which is a good, and air pollution, which is an environmental good. The figure following the next slide will show the quantity demanded as a function of price of gasoline, and the price can be used interchangeably. Marginal willingness to pay is considered as a proxy for measuring the price. The consumer marginal willingness to pay for pollution, MWTP, is a function of quantity of pollution. In the following figure, you will see that the marginal damage from the pollution is precisely negative of consumer total marginal willingness to pay. The total willingness to pay is to eliminate the pollution involves adding up all the marginal willingness to pay as the pollution level expands from 0 to the current level. Basically, how do we decide upon the total, what is the demand for the pollution? We will add up all the willingness to pay, and it will involve adding up of all the marginal willingness to pay for each additional unit of pollution, and then as we move on from 0 level, we will expand the pollution to the current level. So this was the main aspect of marginal willingness to pay concept which is used for deriving the demand curve for environmental good. Suppose we derive the demand curve for a good which is a gasoline. So the graph here, which is on the screens, it shows the marginal willingness to pay for a gasoline. From the prism or the framework of marginal willingness to pay, if we try to perceive the demand curve for the gasoline, we will create a graph where we will have on the vertical axis all the willingness to pay for different quantities of gasoline, and on the horizontal axis we will have various quantities in liters, various quantities of gasoline. Now for a particular price and quantity Q star, P star and Q star, the total cost of accumulating that gasoline Q star is reflected by the rectangle. Over and above this cost, what is there in the triangle, that is the shaded area, is the consumer surplus. So the payments are reflected by the dots in the form of a rectangle, and this on the shaded area, which is a consumer side, consumer surplus, is reflected by the triangle. The shaded area shows the total willingness to pay for the gasoline Q star, and this shaded area consists of payment made, that is a rectangle, and the consumer surplus, which is a triangle. So the entire shaded area, that is the total willingness to pay, is reflected by both the commodities. So the entire area under the graph, the shaded area under the graph, which consists of the consumer surplus plus the payment made by the which is reflected by the rectangle, they both together try to assess or provide us the willingness to pay for gasoline together. Similarly, if we try to derive the marginal willingness to pay for the air pollution, which is an environmental good, not a normal good. So under this we create a graph in this manner, as it is on the screen. Vertically we will locate all the willingness to pay, and horizontally we will have various quantities of environmental good. In this we will create the consumers different level, the marginal willingness to pay for the pollution is reflected in both the quadrants. The first quadrant is a positive quadrant and the lower quadrant, which is a fourth quadrant. So we will have the total damage is reflected on the positive quadrant, reflecting the damage side and willingness to pay on the negative side. So we will have to, for the environmental goods, it is very important to uh, reflect the graph in both the sides. One is the damage side, which is positive quadrant, and the other one is a negative side, which is the willingness to pay quadrant. It is something, the marginal willingness to pay is what is giving us the consumer surplus, while the marginal damage side, which is on the first quadrant, it tells us the amount of the damage it brings about. Additional unit, each additional unit of consumption of pollution brings about a marginal damage. So the total damage is the area covered under the graph. This is the area between the demand curve for the pollution and horizontal axis, and that is shown as a lighter shaded part as shown in part B of the diagram. Thus, for the environmental commodity, the area under the demand curve between the two different quantities is reflected here. Marginal willingness to pay, since there are no payments made, is made for the pollution as there was no, as it was done in the case of gasoline. We saw that in the case of gasoline there was a rectangle that we had along with the triangle, but in case of pollution we do not have the rectangle, since we have not made any payments for the pollution. So for the gasoline we have the payment rectangle, but for the pollution we do not have the rectangle. This is also the consumer surplus. Since we do not have the rectangle, the same willingness to pay is also, it becomes the consumer surplus, though it is lying in the lower quadrant. As you can see, again see in the graph, the lower part which was falling under the fourth quadrant is reflective of the consumer surplus. In this particular consumer surplus, we are devoid of any rectangle. There is only triangle. So in case of pollution, we only have this triangle, and that is reflection of in the fourth quadrant, and that is the consumer surplus. The lighter shaded area is the consumer willingness to pay for the pollution. It is negative since the pollution is bad and the people must receive. The fact that it is negative reflects that people must get compensated for consuming that pollution, and it also tells you the willingness to accept the pollution, how much amount they are ready to accept that pollution. The darker shaded area is considered, which is the upper part, as you can again see in the diagram. The darker area which lies in the first quadrant, which is reflected by the lines, it is that this particular area is the damage from the pollution. So the same amount of willingness to pay which is reflected in the lighter shaded area can be reflected by using the damage cost, and that is reflected in the first half, in the first quadrant. Willingness to pay for the pollution is negative of the total damage. One can see that the total damage is positive, but in case you want to look at the willingness to pay for the pollution, it is considered as the mirror image or the negative part of the total damage. If you can reflect that damage which is lying in the first quadrant, that mirror image that lies in the fourth quadrant is just a reflection of the damage, which is the willingness to pay of the damage, and minus of the total damage will be the willingness to pay for the pollution. This is how one can exactly find out the willingness to pay and consumer surplus for the good case of environmental goods like pollution. However, in the gasoline good case, where a normal good, we have a concept of consumer surplus because we had the market with us, and we could easily find out the amount paid to receive that good or to acquire that good, and the consumer surplus which is left as a triangle. However, in the case of environmental goods, we are shortfall of the cost paid. We just have the willingness to pay, and that willingness to pay reflects the consumer surplus. This is how one can tackle the challenge of assessing the demand curve for the environmental goods pollution with the help of marginal willingness to pay, which can be captured in two ways. One was the damage cost angle, and the other one was from the angle of willingness to pay. They are mirror image of each other. Now let us come to the other section of finding out the types of environmental goods one can think of. Environmental goods can be categorized broadly into two varieties: use goods and non-use goods. Use goods, the concept of non-use value is in the case of mainstream economics. It was first introduced by John V. Trutilla. In the classic article of Conservation Reconsidered, he argued that the consumers need not be active consumers of the resources. They could be indirectly consuming the resources in some way or the other. Its willingness to pay can be captured by price discriminating monopoly owner to derive the value from the continuing existence of the unique irrepressible environmental resource. So there are natural resources which are irrepressible, and they are limited in the quantity. Once you consume them, they disappear from the system and the quantities are limited. So what basically the idea that was floated was, you may not be directly consuming those natural resources, but you may be indirectly consuming those natural resources. You are not the active consumer, but you are somehow making a difference in the quantity of those resources. Therefore, its willingness to pay can be captured by the price discriminating monopoly owners. He suggested that there are two reasons that people should hold, or they hold values apart from the present use. One is the use value and the other one is the non-use value. The one which is a use value, which is a present use, is very direct and understandable. However, people can hold and they have a value which is a non-use value also. One of them is to preserve options for the future use. So people may not be consuming in the present case, but they may be consuming in the future. And its other is bequeathing the natural resources to their next generation or the descendants. An option demand may exist not only among the persons currently and prospective active in the market for the object of the demand, and among others who place a value in the mere existence. So basically, an option demand is also a concept that is developed to reflect the demand for the goods which is just for their existence value, existence of biological or geomorphological variety, and that is widespread distribution. So one can also perceive a value for a particular natural resource, and that is under the category of an option demand, where a person is viewing the particular resource just for its existence and for its biological existence and for widespread distribution availability. So these are certain altruistic values which one can place for the natural resources. According to McConnell, the notion that good is valued only for its existence and that it provides no useful service as far-fetched. So basically, the particular natural resource may not be providing any kind of service, though it may have a, may be carrying a significant value for its existence. The existence value occurs only insofar as a bequest or an altruistic notion of that prevails. Resources are needed because they are valued by others for their either for their next generation or for the future consumption. Thus, use value is the ultimate goal of the preferences that yield existence demand. Though the existence and use may be experienced by different individuals. Today you may have a value, but you may not be consuming the use, it may not be a use value. However, that value may be used, will lead to a use value with the next generation. So different individuals are actually responsible for creating a use value at different point of times. People can have what are essentially existence value out of the unethical or altruistic concerns for the status of, so one can say that there may be an existence value, but that existence value is for an unethical or altruistic concerns for the status of non-human species.